Hello everyone, welcome to another video. So today we'll discuss Igneous Petrology from CUET question. So we'll start from 2020. So let's start from this question that is given. Hypervessel equivalent of rock of basalt. So basalt has can take the plutonic equivalent. It is gabbro, then dolerite, then basalt. So basalt, it is basaltic, dolerite, it is hypervessel, and the gabbro is plutonic. So answer will be dolerite. So the very common question. These are type of question like you have asked what is the volcanic equivalent, what is the plutonic equivalent of the rock. So have your granodiorite. So it is a plutonic rock. It has a volcanic equivalent of dacite. The dunite, it is a monomineralic rock which consists of only olivine. It doesn't have any equivalent like this. Then gabbro, it is the plutonic equivalent of basalt. And take the example, other example like granite. It is plutonic. It has volcanic equivalent, rhyolite. Then we have cyanite. It has trachyte. Then you have diorite. It has volcanic equivalent of andesite. Then we have nepheline cyanite, phonolite. So all these things will can cover from material tabular classification. So these are very important question, very easy question, but it is often asked what is the volcanic equivalent of rock or what are the plutonic equivalent of rock. So these are the main type of rock you have to remember. So answer will be our dolerite. Next question, so chilled margin. So chilled margin are often under the condition of. So what is chilled margin? You can say a margin that rapidly cooled. So when an intrusive body enter into a country rock, intrusive body, you can take the example of dike, you can take the example of seal, you can take the example of other like batholith, or when they intrude into the surrounding country rock, then the margin of the intrusive body, they suddenly come in contact with the country rock. So country rock is cooler, this is hotter. When the contact point will rapidly cool, this point will rapidly cool. This is called as your chilled margin, and it is often you are indicated by fine grained rock. Fine grained rock, because rapid cooling always produce fine grained rock that doesn't have sufficient time to grow larger crystal. So any chilled margin that produce the margin of an igneous intrusion, they indicate fine grained rock. So they indicate rapid cooling, because a hotter thing suddenly comes in contact with a colder thing, there will be rapid cooling. So answer will be here rapid cooling. Then next question, which one of the following rock is generally found in island arcs? So island arc is a feature that produce during convergent plate boundary, where two plates converge with each other. Then the subducting plate, it produce volcano, and they produce an feature that is called island arc, or you can say volcanic arc. Volcanic arc. So when there is the involvement of oceanic crust and continental crust, or oceanic plate and continental plate, during subduction the oceanic plate is more denser, so it will be the subducted plate, and continental plate is the lighter one, it will be the abducted plate. Then oceanic plate that subduct produce partial melting because of volatile flux. Then these melted or generation the generated magma here, they rise upward, and under plate here and they produce volcano by traveling through the continent. Now see, when these magma produce from the oceanic plate, they are basaltic. While these basaltic magma, they travel through continental plate, which is acidic. So the final result will be intermediate magma. Intermediate magma. So here intermediate is your andesite. It is andesite. So always remember, during convergent plate boundary, during your convergence of two plates, if there oceanic and continent involved, they produce magma which is intermediate. So that magma is called as andesite, which is a typical rock of convergent plate margin. So answer will be andesite. Granite, it is produced from continental crust. Only when partial melting of a continental crust occur, they produce acidic volcanism because granite is acidic. So granite produced by partial melting of continental crust. So then comes to pegmatite. So pegmatite is rock that produce at the latter stage of the magmatic crystallization because of addition of volatile. So pegmatite, remember, it is called as your mineralogical museum. All type of mineral find in pegmatite, and pegmatite is also known for its coarse grain because pegmatite produced when magma is highly charged with volatile content, or more you can say addition of water. So in that condition, pegmatite produced. Dolomite is a sedimentary rock, consists of calcium and magnesium. So our answer will be andesite. So next question, it is given a visible quartz potassium feldspar. Visible quartz potassium feldspar means you have phaneric grain. You can see in your naked eye. The grains can be seen on naked eye. So when this type of thing asked, if you remember, if there is visible or any grain within a rock, you can see in your naked eye. So that means the rock produced under greater depth. That means the rock is plutonic. So we have visible rock fragment of quartz and potassium feldspar. So quartz and potassium feldspar are essential constituent of granite. So granite and visible fragment, granite is plutonic. So answer will be granite. Ravelite is also of same composition, quartz and potassium feldspar, but it is volcanic. So it has fine grain. It doesn't have visible fragment of visible quartz and potassium grains. Then gabbro is plutonic, but it has different composition. It contains olivine pyroxene, that is your gabbro type of rock. You'll find plagioclase, pyroxene in gabbro. Then dolomite is also same. It is a hypobasal equivalent of gabbro. Gabbro, dolomite, and basalt. So our answer will be granite. Then comes to mantle plume, responsible for the Deccan large igneous province. So Deccan LIP, large igneous province, it is a continental flawed basalt. It is an intracontinental volcanism that occur within the volcanism within the continent. So most of the volcanism we find at the plate boundary. They convert to the plate boundary. You can take the example of ring of fire, which is produced at the Circum-Pacific belt. But you also found volcanism within the plate, that is called as intraplate volcanism, that because of presence of hotspot or mantle plume. So, so our Deccan volcanism, it occur because of this reunion hotspot. When Indian plate that moving over the reunion hotspot, they produce a volcano, that is, or you can say igneous province, that is called as Deccan igneous province. So answer will be reunion plume. Then we have already discussed this Kerguelen. So Kerguelen, because of Kerguelen, you will find 90 trees here and also Rajmahal trap. Then Marian, it is you can say oceanic hotspot, and Tristan is also in the mid is the Atlantic Ocean. So these are other two volcanism, or we can say hotspot. So our answer will be reunion hotspot. So next question, your anorthosite dominantly composed of. So anorthosite is a rock. It is called as a monomineralic rock. Monomineralic rock. So we know the definition of rock, it is aggregate of minerals. But why will say monomineralic rock? Monomineral means it consists of a single mineral. That means it consists of 90 or 95% of a single mineral. Other accessory mineral are present, but they are very less percentage. So that's why they are called as monomineral rock, because of dominance of a single mineral within a rock. So anorthosite is such a rock that consists of 90 to 95% of labradorite. Labradorite, so which belongs to plagioclase series. So answer will be plagioclase. Then sanidine, microcline, orthoclase, they all are potassium feldspar. Then you can take another example of monominate rock like dunite. It consists of only olivine. You can take the example of your pyroxenite consists of only pyroxene. And take the example of marble, would consist of limestone. You can take the example of quartzite, consists of quartz. So those are monomineralic rock. So come to next question. Which of the following mineral is the most suited for UPB dating? Uranium PB dating. So the mineral that can contain uranium will be suitable for uranium dating. So among these minerals, we have zircon. So zircon contains Zr and we have uranium. Both have valency of 4, so they can easily replace each other, and they have also same size. So here uranium cannot be occupied within the quartz, or they can be occupied very little within the feldspar and olivine, but zircon is the main constituent. Then zircon, zircon, it cannot incorporate Pb. It always reject Pb. That means in zircon, the Pb you will find all are produced from the uranium. That will be very helpful for radioactive dating. So that means in in zircon all the Pb are radiogenic. Then zircon also, it has high you can say weathering resistance, so that it can withstand a very longer period of time. Then another thing, zircon has very high closure temperature. So closure temperature, or you can say blocking temperature, where zircon uranium incorporate into zircon approximately at 900 degrees centigrade. So that means uranium that is incorporated into zircon can be stable up to 900 degree temperature. So that's why during high grade of metamorphism, which is up to you can say 700, 800 degree temperature, uranium will be still within the zircon. It will not release from the zircon. If you increase the temperature more than 900 degree, then uranium will remove from the zircon. So that is also another cause where zircon is very suitable for UPB dating. So first thing, uranium can replace zircon because of their same charge and same size. Second thing, they have a very high close temperature, so that zircon can withstand high degree of metamorphism without releasing uranium. Then zircon usually reject Pb, so that all the Pb you will find in zircon all are radiogenic. So answer will be zircon. Then a rock is made up of euhedral crystal. The texture is described as. So there are you will say 3 type of texture, which we will called equigranular texture. They consist of all equal sized grain. There are 3 types. One is allometric, hypometric, panidiomorphic. So allometric consists of all anhedral grain. All anhedral grain. Hypometric consists of all subhedral grain, and panidiomorphic consists of all euhedral grain. So rock made up of euhedral crystal will be your panidiomorphic. You can take the example as lamprey. Lamprey, it is a rock that consists of all euhedral grains. Lamprey is also so a characteristic that is called as your dualiomorphism, where unusual occurrence of alpine, quartz, olivine, and pyroxene. Then hypodomorphic, take the example of granite, those are hypodomorphic. Then allotromorphic, you can take the example of apathites. So these are all your equigranular texture. Next, it is a very important question or important concept, you can say, ophiolites. So ophiolites, it is a part of the oceanic crust that preserve on the continental crust. So that occur in the convergent plate boundary like this, when part of the oceanic crust that scrapes out or break and preserve on the continental crust, that is called as your ophiolites. So the process of formation of ophiolites, or you can say scraping of oceanic plate or breaking of oceanic plate and preserve on the oceanic continental plate, are called as your abduction. Called as your abduction, opposite of subduction. So ophiolites, remember, it is a part of oceanic crust that preserve on the continental crust. You will find in continental collision region, you will find in back region. So different part you will find ophiolite. So ophiolite give you information about the layer of the oceanic crust. So ophiolites are the part of the oceanic lithosphere. So ophiolites always show a particular layering. It is also very important for different type of exam, where always asked to you can say sequence of ophiolites. So this is a sequence of ophiolites. First, on the base you will get ultramafic rock like dunite, hasbergite, dikes. Then you will find chromites here, weyerite. All these are ultramafic rocks. Then above that you will find layered gabbro. Then you will get foliated gabbro or isotopic gabbro. Then you will get seated dike. Then below lava. Then deep sea sediments, or you will call them as pelagic sediments. So these are the common sequence of a ophiolite, where on the base you will get ultramafic, then layered gabbro, then you will get this foliated gabbro or isotopic gabbro, then seated dike complex, then pillow lavas, then pelagic shell or deep sea sediments. So try to remember this sequence, it is very important. So next question, the volcanic equivalent of diorite. So we have already discussed this. The volcanic equivalent of diorite, it is your. So come to the next question, the volcanic equivalent of diorite. So already discussed, the volcanic equivalent of diorite is andesite. Cyanide, it has trachyte. Cyanide is plutonic, it is volcanic. And monzonite, it is a type of rock, saturated rock, you can say, which contain 50% plagioclase feldspar and 50% orthoclase feldspar. That means it contain feldspar of equal amount, both alkali and calcic. So it is important, remember, monzonite contains 50% plagioclase, 50% alkali feldspar. You can check this from your IUG's classification of plutonic rock. So answer will be monzonite, sorry, and andesite. Then this is also a data question, you have to remember what are the composition. So first thing, your nephelinite. So nephelinite composed of, so this is our nephelinite. It is a volcanic rock that contains nepheline, cyanopyroxene, and olivine, but it lacks feldspar. So it doesn't contain any feldspar. So in our option, you'll get these two will be discarded because they contain feldspar. Then we have nepheline, cyanopyroxene, olivine. This will be the correct option because it contains olivine and nepheline. Then these are other type of rock. So try to remember all these composition. Question might ask from this, like basanite, it is feldspar bearing basalt. Then tephrite is olivine free basanite. So isolite is an important, it is plutonic nepheline pyroxene rock with 30 to 30% of nepheline. Then we have phonolite, it is also an important rock which is volcanic, it has a plutonic equivalent of nepheline, cyanite. It is also, you will find in Tyrrell tabular classification. Then these are some alkali rocks also. Among these, more lamproite, lamprophire, kimberlite, and carbonatite is very important. So carbonatite is a rock which contains more than 50% of carbonate mineral. like calcite, anchorite, those are all carbonate mineral. Then kimberlite, it is a volatile rich potassic ultramafic rock. Then lamprophire and lamproite, well, you can say ultra potassic rock. That ultra potassic rock. So next question, petrologic nature of oceanic lithosphere is generally enhanced by studies of ophiolites. So we discussed this in previous question. It is correct because we know more information about the oceanic lithosphere by studying the ophiolite, because ophiolites represents the layers of the oceanic crust. So ophiolites are considered the mass of the oceanic crust and upper mantle that thrust into the edge of the continent that we discussed, that is called your abduction. So it is also correct. So both the statement 1 and 2 are correct. Then silica undersaturated basalt. So it is already said it is undersaturated basalt. So will evolve through trachyte and eventually form. So this diagram is called as TAS diagram, total alkali silica diagram. You can see this is basalt. If this basalt is undersaturated, then with progressive crystallization there will be little amount of increase in your silica and alkali. So that's why it evolved like this. Basalt, then trachyte, then phonolite. Basalt, then trachyte, then phonolite. So answer will be phonolite. So here remember another thing, if the magma is alkaline, then it ends with phonolite. If the magma is your subalkaline, it ends with rhyolite. So come to another table match question. These are your you can say igneous forms. So igneous forms can be classified into two types. One is your intrusive, extrusive. Then intrusive can be divided into two types. One is concordant, one is discordant. So concordant, it is when the igneous intrusive structure they are parallel to the bedding plane. That is concordant. Always remember, concordant does not means it is horizontal. Suppose let's take the example. Suppose we have a bed like this. We have a bed like this. So if there is a igneous intrusion, is like this. This also concordant. If it is like this also concordant. That means any igneous intrusive structure that parallel to the bedding plane, they are concordant, not that it is horizontal. Similarly, if it is cross-cut the contour rock or bed, it will be your discordant. So let's see, batholith, it is both concordant and discordant. Main characteristic of batholith, it should have an aerial extent more than 100 square kilometer. So so this option, very large intrusion with surface exposed over 100 kilometer. So batholith, it is granitic to granodiorite in composition. So batholith, it isolatedly exposed on the surface, which is called as a boss or stock. If the exposure is regular, it is called as a boss. If the exposure is irregular, it is called as your stock. Then dike. So dike, it is a discordant structure. So vertically discordant intrusion, often composed of dolerite. You can say dolerite dikes or basaltic dikes. So frequently exist as swamps. Then seal. So it is a concordant structure, sheet-like. So you can take aerially extensive, small intrusion, sheet-like. Dike and seal both are your basaltic in nature. Then roof pendant. This is a contour rock surrounded by igneous intrusive metal. You will find in batholith. So if any contour rock, they surrounded by your igneous intrusion, that is called as a roof pendant. So our answer will be batholith is second, dike it is 4, C third, D I. So A will be your answer. See another same type of question. These questions are repeating again and again. In each year, mostly you'll find these equivalent questions. So it is very important. So you either study the tidal tabular classification where you remember all these volcanic and plutonic equivalent, or I already told about all the volcanic equivalent and plutonic equivalent of rock. So volcanic equivalent of granite, it is rhyolite. Then dacite, it is a volcanic rock which has plutonic equivalent. Your granodiorite is plutonic. Trachyte is basaltic, it has plutonic equivalent of CN8. Basalt, it is basaltic, it has plutonic equivalent of gabbro and hypobasal equivalent of dolerite. So next question, we have two statements. Entire zone or area recrystallized content rock around an igneous intrusive body named as contact aureoles. So this question should belongs to metamorphic petrology, but still. So contact aureoles means, suppose we have an igneous intrusion to a country rock like this. Then this igneous intrusion will affect the surrounding country rock because the igneous intrusion is hotter and surrounding country is colder. So it will affect the surrounding country rock and produce metamorphic rock around it. So this entire zone is called as your contact areoles. So they produce your thermal metamorphism, where the degree of metamorphism decreases away from the intrusion. So general you will find hornfels texture in this type of rock. So this is called as a contact aureoles. So this is true. So these spotted fine grained recrystallized rock are called myolinites. So it is incorrect. So we can call them as hornfels, or the characteristic structure is hornfels structure or granular structure. But myelinite, it belongs to a fault zone metamorphism where produced under ductile condition. So statement 1 is correct, but statement 2 is incorrect. So answer will be C. Then plutonic rock generally exhibit. So plutonic rock, so it is produced at a greater depth. So igneous rock can be divided into three types on the basis of depth of formation. One is plutonic, which is produced at greater depth, then hypobasal at intermediate depth, then volcanic at surface. So among the options, schistose is metamorphic, glassy texture. It is indicative of rapid cooling, which is volcanic condition. Pyroclastic, it is also volcanic condition. Then your phaneritic texture. Phaneritic means you can see the grain in naked eye. That means there is greater development of or more development of grain. There will be larger grain. So larger grain is characteristic of deep seated condition, which is the characteristic of plutonic rock. So answer will be D. So phanetic texture, it belongs to plutonic rock. Then lava. So lava refers to, obviously these are liquid product of volcano. So generally we use two terms. One is your magma, other is your lava. So the melting or molten material that produced by melting of lithospheric plate or take the asthenosphere. So when they produce in the subsurface region, you can say below the surface, they are called as a magma. They are also molten and liquid. When they rise upward and come to the surface, they are called as your lava. So molten rocks that erupts from a magma, you can say. Below the surface, they are called as magma. The solidified deep below the crust, they can be called as your intrusive rock body. Then plutonic igneous rock, they are intrusive rock body. So that means plutonic rock that erupts from a volcano are called as your lava. Then comes to aphanetic texture. So aphanetic texture, it is generally exhibited by. So we have two types of texture on the basis of grain size, what we call granularity. It's called as your granularity. So granularity indicates the size of grain. On the basis of granularity, we divide the texture of igneous rock into two types. One is phaneric, one is aphanetic. Phaneric, you can see the grain under naked eye or with the help of a pocket lens which have a zoom of 10x. Or aphanetic, which cannot be seen under naked eye, you have to use a microscope to see the grain. So always remember the fine grain are indicative of rapid cooling, which is generally characteristic of volcanic rock, or you can say extrusive igneous rock. So aphanetic texture, it is generally volcanic or extrusive igneous rock, because metamorphic rock can be fine grain, can be coarser grain depending upon the grade of the metamorphism. The higher grade, the more larger grain size you'll find. Sedimentary rock, it does not, all the sedimentary rock are not fine grain. Then gneiss is also metamorphic rock, they contain coarser grain because they are high grade metamorphic rock. So where our answer will be volcanic or extrusive igneous rock. Then comes to symplectic texture. So symplectic texture, it is an intergrowth of two minerals, but it is in microscopic scale where you will get vermipolar shape grains. You can take the example of quartz and plagioclase. They show symplectic texture, and symplectic texture mostly occur in metamorphic condition. So it is an intergrowth texture. Symplectic also you will find in olivine and pyroxene in eclogite. Then next question, explosive volcanic eruption are mostly associated with. So explosive volcanic eruption, it should occur at lesser depth with more volatile content. So such magma are felsic magma, they produce under lesser depth and contain more volatile matter, that is in dissolved condition. When they come to the surface, the pressure will decrease and the volatile matter will release, producing more explosive condition. You can take the example of the opening of a Cotris bottle where the volatile matter or gas, they are in dissolved condition under pressurized condition. When you release the pressure, they suddenly comes out producing your bubbles and also produce sound. So that mechanism also apply in case of explosive volcano where acidic magma, they have more dissolved volatile content, they produce at a lesser depth under direct pressure. When that pressure release, the volatile matter will release, producing more sound, you can say, more explosive and more I can say more denser magma because of release of all the volatile matter. So answer will be felsic magma. Then in the discontinuous side of the Bowen section series, under normal condition during cooling processes, the mineral crystallize in the following sequence from higher to lower. So Bowen section series consists of a Y-shaped series where this is your discontinuous part, this is your continuous part. So discontinuous part you will get, you can remember old people are boring. Old people are boring. O for olivine P for pyroxene, A for amphibole, B for biotite. Here you have K feldspar, then moscovite, then quartz. And these are continuous series which consist of plagioclase series starting from albite to anorthosite. So discontinuous series we have to arrange from higher to lower. So it started from 1100 degrees centigrade to 573 degrees, that is quartz. So follow the sequence. Old people are boring. Your C, D, A, B. Option B will be correct. So next we have a table mass question. This is pedutites. So pedutites are, remember, ultramorphic rock. The ultramorphic rock means they contain 90% of magnesium iron content. So we'll take the example of your Hasbergite, Wehrlite, Websterite. They all are ultramorphic rock. We have a famous triangular compositional diagram for this: olivine, OPX, CPX. It is very important for all entrance. So olivine, OPX, they produce Hasbergite. Is Hasbergite. This is Wehrlite. This is Websterite, and this is lazulite. All these rocks, your Hasbergite, lazulite, they all are your pedutite type of rock. Hasbergite, lazulite, Websterite. So they all contain olivine and pyroxene. That means they contain magnesium and iron up to a 90% or 90% above, more than 90%. So pedutite, it is an ultramorphic igneous rock. Then pumice. Pumice is a felsic rock which has which is volcanic, which is lighter in color, which has main characteristic, it is highly porous, so that it floats on the water. So it is a glassy rock, so that it has non-crystal. It come under non-crystalline igneous rock. Then rhyolite is a felsic igneous rock. It is volcanic equivalent of granite. Granite is felsic. Then basalt, it is mafic, which contain magnesium and iron. So our answer will be A is 4, B third, C 2, D 1. So A will be the answer. Then arrange the following mineral according to their order of crystallization from a cooling magma. So it is also belongs to your Bowen section series. The question belongs to Bowen section series. So here given hornblende, it is amphibole. Augite, it is pyroxene. Then quartz. So past that will be olivine. So past that will be, there is no olivine here. So we will take from pyroxene. That is C. Then your amphibole. Then biotite. C D B A. First there will be amphibole, first there will be pyroxene, then amphibole, then biotite, then quartz. C D B A. Option D will be correct. Then ophiolite fluid that we have discussed in previous question. What are the different layers of ophiolites? So ultramafic layers, then you will find layered gabbro, your foliated, then isotropic, then sheeted dike, then pillow basalt, then your on the top you will get pelagic sediments or ocean sediments. So in sequence you will get first gabbro, then basaltic dike, then pillow basalt, then pelagic shell. Then diagram A, B, C, D, top to bottom. So answer will be A, B, C, D. So this is all about your Igneous Petrology question of CUET exam from 2020 to 2025. So I have also published other PYQs. If you have not seen them, so you can search from our channel, that your MSc Geology search channel. And there is a playlist called CUET 2026. You will get all the CUET related video from that playlist. So this is for today. Thank you for watching.